Hello, everyone. Welcome to the Day Zero podcast. We're on episode number 16. I'm Spectre. With me is Z. Auntie's not with us today. Before we jump into topics, we do have some meta discussion. So we should talk about the YouTube uploads first, I think. The YouTube uploads for the VODs are going to be going up a little bit later. For those of you who didn't tune in last week to any of the streams, we did get Twitch affiliate. And because of that, we're going to have to delay the YouTube VOD uploads by 24 hours. So
Yeah,
the
that
VODs are going to
also
be a little
does
bit later.
include our the anchor episodes. So all of our audio things will also be coming out 24 hours later until we're able to negotiate and have enough of a following to negotiate with Twitch on that. So if you do want to catch us live, the first access will be here on Twitch.
Yeah. And I mean, if you can't catch it for some reason, the VODs will still be up on Twitch and the Twitch videos, but yeah, they just won't be on YouTube or on the audio only streams. And the other thing we want to talk about is we are going to be doing exploit streams every Friday night. We're gonna try to do that. So I've been doing that the last couple weeks. Last week I streamed actually quite a few days. I did like Wednesday, Friday, Saturday. So we may stream even more than those days, but those days we're gonna try to hit like 100%. So just wanted to talk about that. Was there anything else you wanted to bring up, Z? Am I forgetting anything?
I think the other thing to bring up is just that we are also going to be making some changes to our social media accounts. I mean, our Twitter and Anchor will both kind of follow the same naming scheme that we have here on Twitch, which is that day and then zero spelled out. Right now, we kind of have a quite the mix of kind of names that we're using, so we're going to try and standardize that a little bit. Um, Other than that, no, I think we can jump right into kind of our first topic.
Okay. Before we do the topic, I just want to say I tweeted this out on Twitter, but I'll say it on the podcast because I thought it was just so amazing. Is like Mr. Robot did an episode yesterday with only 2 lines of dialogue in it, and I thought that was pretty damn incredible. So much so that I wanted to shout it out on the stream.
Yeah, you were mentioning that, unless you were paying attention, it wasn't obvious that it was just a silent episode.
Yeah.
I'm a bit skeptical, to be honest. I haven't been watching this season of Mr. Robot, so I can't actually comment on it. I mean, and especially now that you've mentioned that's a silent episode, of course, when I watch it, I'm
Yeah, I
going to
know.
know it. So you've ruined that for me, but
Sorry. Yeah, no, it was a really good episode. So, yeah. All right, so we're going to talk about Humble Bundle now. I just wanted to shout that out a little bit.
yeah, and this is really just another quick shout out here with Humble Bundle. It's not a security one. Usually around this time, like I'm expecting one of the next bundles will be more security related. There's usually something around Christmas time. Nonetheless, it's a no starch press. They've had some great books. I mean, a ton of the books I like to recommend for security related stuff absolutely come from no starch press. So I mean, if you want some more Linux folk stuff, I'm sure these are good. I can't really review a ton of these, but do kind of want to mention like the bundles there. Check it out if that's something that actually interests you.
I'll be honest, just judging by the titles and stuff, it's kind of weird. It seems like the best books are actually in the $1 tier. Because like I think the Art of Debugging and the FreeBSD device drivers are probably like the best books in the bundle, and yeah, they're in the $1 tier. So I thought that was kind of weird. Because some of the ones on the upper
Yeah, I
tiers, they
mean, I
look very
know
surface level, like how to use the command line and stuff. Like generally,
I,
it's more beginner oriented than some of the other ones.
I have seen the book of PF recommended a fair bit. Obviously, if you're doing anything on OpenBSD
What is PF? Oh, yeah, right.
firewall, yeah,
Packet filter, yeah, or whatever it is, yeah.
yeah.
Okay.
No, you're and actually, so Linux basics for hackers. I remember seeing this one, and I mean, you see the picture there, the talks and stuff, and you kind of expect it to be a pretty cringy book.
Yeah, that was
Now
my initial thought
I'll
on it.
admit I don't remember anything in it, but I do remember that it didn't seem that bad when I looked. I think I had seen like one of their like the smaller copies that they released before they actually put out the book.
Okay.
Um, and it didn't seem that bad, but again, I basically don't remember anything, so that maybe speaks for itself too.
Okay. All right. Well, we'll jump into Apple v Corellium then, because I think that's all we have on the Humble Bundle stuff. So
Yep.
this was pretty crazy. I looked into this as soon as it came out. I tried to find the case documents. So for those of you who don't know what's happening here, Apple sued Corellium, trying to say that they basically what was like infringed on their intellectual property. So Corellium, it basically they provide a service for you to test on iOS devices without actually having an iOS device. They're like virtual devices that you can access online.
Yeah, to be clear, this is separate from like what Amazon provides and such with their mobile testing, where they kind of do a screen capture on an actual device. And that is kind of an essential difference here too in terms of Apple's case, because Apple's terms of service and the EULA kind of disallow that level of like basically running Apple software on non-Apple hardware. Whereas Google and stuff can get away with it by just doing screen captures of it. Corellium was a full VM.
Yeah, which is actually kind of incredible when you think about how like customized Apple hardware is and stuff. But yeah, I mean, from what I know, Corellium, it's all their own stuff. It's not like they stole any of Apple's code or anything directly. Um, so yeah, Apple tried suing them, and the reason, like Corellium, I wish I had a bit of experience using it, but it's very expensive. Like I think I remember hearing the figure $1 million being thrown around just to get access to it, and they don't invite everyone. You have to be like a pretty known figure in the iOS community. But yeah, so they're suing them, and so I think Corellium's countersuit, they ended up saying that Apple approved of Corellium in the Secure Bounty program, um, but they didn't they didn't pay it out. They
Yeah, so I mean, my question though is I don't know what the terms are that Apple actually lays out. Like, I do think there's a pretty clear case for Apple in terms of them suing over the copyright DMCA, because DMCA does allow for some exceptions for reverse engineering and security, which Corellium is kind of hiding behind, saying that people getting access are, security research or security companies using it for that sort of research and testing. So they're kind of hiding behind that, but one of the requirements with that is that DMCA doesn't let you violate the EULA. So if you violate the EULA in the process of violating any sort of copy protection, it's not protected. It's not a um, it's not. It no longer falls under the exception. I'm getting a little bit of feedback from you, Spectre.
you're getting feedback. Okay. I'll try something real quick. Just try to fix it.
But just kind of carry on there. My thought, like, I kind of have the question as to whether or not Corellium's going to be able to stand up against this. Like, Apple does have pretty clear terms, and while they did have that tacit approval that Spectre kind of mentioned, where they were allowed onto this bounty, one, I mean, they could have been allowed on that without Apple having full understanding of how Corellium worked and their actual infringement. I mean, there's definitely things Apple can say there. And I mean, even so, like, it's basically them turning around the case and being like, hey, Apple's being like, hey, you're infringing on the copyright, you owe me this much money, and Corellium just kind of turns that around and is like, no, you're you actually owe us because of all these bugs that so they actually have a list of kind of the bugs Apple didn't pay them out on.
Yeah, so I did want to bring that up. I thought that was kind of weird, like to bring up in a legal document, mostly because like most, lawyers and judges and stuff aren't really gonna understand what any of that shit means anyway. So I'm not really sure why they like talked about the specifics of the like some of them they leave vague, like memory leak bug, kernel execution bug, but other ones they get more specific, like POSIX spawn issue and persona race condition. So
Well,
I'm not sure.
that's
Like
not that specific. POSIX spawn
it's
issue.
more specific than just memory leak bug, though. You know
Well,
what I mean?
it's just saying where it is though,
Yeah,
and like it's not really being that specific.
yeah. But I just
I
found it interesting that they included that list entirely.
Yeah, I mean, I have to imagine that they can't really make any claims though about wanting payment for something if they can't actually illustrate what it was that they did.
Yeah, fair enough. Um, But yeah, I tried to get the full legal document because I honestly wanted to read through it because I was curious, but it's behind a massive paywall, and I am not paying like $50 or whatever it was to read the
Yeah,
document.
I didn't get access to it either.
Yeah, but like from the screenshots, like, I mean, Apple hasn't exactly had the best reputation with their bounty program. I remember QWERTY had an issue a few years ago where he submitted a bug, and instead of paying out to him, he wanted Apple to pay out to a charity. It was I think it was like an MDMA trial. They were trying to see like if it helped with PTSD or something like that. So it was a legitimate charity, and Apple refused to pay it out because they didn't want to pay out to that charity. So Apple's
Yeah,
had
I
payout
remember
issues
that,
before.
but I mean, I think again, something comes down to what are the actual terms of Apple's bounty, and I mean, because it's a private bounty, basically
Yeah,
have
we don't
no
know.
idea what their actual terms are. Like, it's possible. I can't imagine that it's the case, but it is possible that they actually had like a qualifier in their payouts being, we have to pay out to a specific individual or something like that, or like we only pay out to members of the bounty program. So, something of that nature could have existed in there. I don't know, but like it's possible that that's in there.
Yeah. So, I mean, we may get the full legal document in time. I think the thing with Pacer Monitor is they paywall it because it's like first access. I think it does go free after like a month or something like that. So, we may
Yeah,
be
and I
able to
mean,
talk about
we'll
it
get
more in
more
detail in a
information.
discussion or something later on.
Yeah, we'll get more information though too, like once the case actually starts closing out.
Yeah. Yeah, exactly. All right. So, oh yeah, I just gotta close that real quick. All right. So, the Mozilla stuff. What were your thoughts on their proposed change to remove the side loading ability?
Well, so it's not just a proposed change; like it is coming.
Or sorry, yeah, just the proposed change. Yeah.
I mean, so the first thing was I saw a lot of FUD over this, like a lot of misinformation about what this meant.
Okay.
Specifically, and even though it's right here in the first thing, side loading is a method of installing an extension in Firefox by adding the extension file, adding the extension file to a special location. That's what this is about. What it's not about is just the ability to kind of install or manually install like XPI files. You'll still be able to do that.
Okay, so I don't do much extension development, so that's probably a distinction that's important that I didn't really see anywhere in the article or anything.
Well, I mean, it's there in that first paragraph, so I was saying. It's side loading is a method of installing Firefox by adding the extension file to a special location. Basically, what this is I I believe LastPass, like when you install something like LastPass, it'll try to automatically install its extension. What it does is it just drops its extension into like your Firefox profile extensions folder, and that installs
Okay.
it. That's side loading.
Okay, I see. Okay, that makes more
Um,
sense. Yeah.
I mean, because you kind of have the idea of side loading in the sense of like a phone app, where side loading is basically just loading any app outside of the store, which isn't what this is. Kind of is. Um, with this, once this is in place, you'll have to install all of your apps through the add-ons page. So you can still drag your XPI file onto the add-ons page and install it like that. It doesn't have to be through their store, but it does have to be through their interface. So it'll show up and be removable from their interface. Because
Okay.
that's kind of the issue. Malware could install itself through the side loading method, and you have no way of knowing it's even there or doing anything because one, you didn't add it, and two, it doesn't show up as an add-on.
So you think this is a good change overall?
I think
Or
so. I mean,
okay.
maybe if I find out, like, I do know that they've been locking down things in terms of signing and self-signing. I mean, so if this has something I'm not aware of that's related to that signing aspect, like if you have to, like on the Chrome store, you have to publish to the Chrome store in order for people to be able to install it. Which means you have to pay Google if you want to do something that's only for your organization.
Okay, I can
So
see
I
the
mean,
worry
if
there.
Firefox goes that route, I'd have some concerns. It doesn't seem like that's quite what they're doing yet. You do need to sign, or extensions do need to be signed by them, but you don't need to publish it through their store.
Okay. I guess one thing I was wondering when I was reading this is why not keep it but make it a disable by default and then have a setting where you can allow side loading, but it just gives you like a big, like red banner saying, this could be potentially dangerous, but if you want to do it, you can. You know what I mean? Because I think that would be a better solution to it,
Maybe,
personally.
but I mean that doesn't. I mean, programs can also tamper with your about config settings in Firefox. I mean, you can have it preload a .cfg or whatever. I don't know the full method. I've done it once or twice. Um, so I would have some concerns over the actual security of that.
Okay. All right. Yeah, fair enough. Yeah, I mean, I looked in the responses and I saw a lot of people that were like, "You're removing the one thing that makes me use Firefox, so I'm gonna move to Chrome or something like that." Like, there was a lot of people who were really upset about it, so that's why I was curious to, because I know you like to use Firefox more than Chrome, so
Yeah,
I
like I
thought your
mean,
opinion would be a lot more of value than mine.
yeah, I definitely use Firefox as my main thing. And when it comes to the extensions, this isn't removing your ability to install extensions manually or like anything that's just distributed as that XPI file. So this isn't that key feature being removed. The title makes it seem that way. Like this is just a kind of fail on Mozilla's part because I mean, it's clear in the article, but just because of that title, which so many people are only going to read that title.
Yeah, yeah, exactly. Gotta. It's the Reddit mentality, man. Read the title, nothing else. All right. So the delegated credentials for TLS. Did you manage to take a look? Oh, something's up with the page. It's not letting me go back over to the.
Oh yeah, that's
Hmm. Okay.
definitely intended.
Yep. It's not a bug. It's a feature. All right. Anyway, Cloudflare put out
Yeah, I'm not
this
sure
blog post
what's
about,
up there.
yeah, about delegating credentials for TLS. So as far as I understand it, this is like a technology they're putting out so that you don't have to give organizations like Cloudflare your pub or your private key. You can basically use your server and they contact the server you have the key on to do any operations that need the key, and then it sends it
No,
back.
no.
Okay, so maybe I'm wrong on
You're
that. So
so you are thinking of something Cloudflare has. You're thinking of their keyless SSL, where you would, as a running whatever, you would provide kind of like a key server, and then Cloudflare, whenever a connection comes in, they'd contact you, ask you to like do this decryption, and then you send it back. So like there's that round trip to the key server that Cloudflare would have to do. No, so and that was kind of like I mean, it's essentially just offloading the RSA. That's what the keyless SSL was.
yeah.
So no, what delegate credentials? This is more than just Cloudflare. This is also something that's been done by Facebook and Mozilla. They've both put out blog posts here. I felt like this Cloudflare post was kind of the had the best information about kind of what was going on here. So the gist of this, first of all, I do want to mention kind of the problem is for a long time, in addition to the issue of just giving the CDN your certs, the other thing is when a cert gets compromised, when your cert lasts for like 1 year, 3 years, that means there's a significant period of time where people can use that cert for like man in the middle attacks or whatever. So then Let's Encrypt kind of came out and they've been doing 3 month as their normal. Which kind of just that shorter period means once it's compromised, there's only that shorter period for it to actually be used in an attack. And then with delegated credentials, we're getting down to having keys that last only hours. So that's also part of it, or an important part. So as I said, we've already kind of talked about the keyless SSL, which is kind of their first attempt. That was back in like 2014 when they first introduced that. But now this new feature is kind of being pushed right into TLS. They've got a spec written out for that. It's an open spec. It's not like something that's proprietary to Cloudflare.
Okay.
Where rather than doing this, where it would go and access that key server, what would end up happening is basically you have the gist of it is the key server will push a delegated credential to the CDN, and then the CDN, instead of signing things with the actual private key, they'll show this signed certificate or delegated credentials saying like, hey, I'm allowed to use these credentials and I'm going to use this for whatever. And then they use that delegated credential to then sign the request and do all the normal encryption.
So it's basically like a temporary key that
Yes, it's a
expires after a
temporary
couple hours.
key.
Yeah.
And so they don't have to give one long-term access and two the actual private key over to Cloudflare.
Yeah.
Or over to any sort of CDN. And I mean, that's becoming a bigger problem as the internet's growing, having that level of access. I mean, there's definitely concerns about third parties having access to the keys. I mean, we just talked about the Nord one. Now, this wouldn't have really, actually, this may have helped with the Nord one even in terms of the lifespan, because that was a several year cert.
Was it?
What?
That
Yeah,
long?
yeah. It came out. I think it was 2015 to 2018.
Okay.
So like that. So like something like this would have helped with that if there was only like a 3-year-old cert, or sorry, not 3-year, 3-hour-old cert. Like, it's a lot less useful. I mean, to be fair, a lot of these attacks, like, they require somebody that's in the network that's like kind of right there with you to do some sort of man in the middle. Yeah, there are a few attacks like the ISP level, but those are basically, the wider the attack, the more rare they become.
Yeah. I mean, the main thing I saw them trying to tackle with this blog post when I was reading it is, for one, because it's pulling it every couple hours instead of doing it on every request, it reduces the latency. And the other thing they were worried about was potential downtime, because if they couldn't reach the key server or something like that, it wouldn't, there would be downtime there. And it seems like, if it's only doing it every few hours, there's less of a chance of that happening. So that seems to be like the main focal points of what they're doing.
Yeah, I mean that's definitely part of it, because having the requirement like you're using a CDN and now you need a high availability server for the CDN to then use. That's an issue for a lot of companies. Like, they're using a CDN because maybe they don't have the best availability.
Yeah. I did just want to ask, what was it exactly? Because they mentioned Facebook and what was the other company? Facebook and something
Mozilla.
else. Mozilla. Yeah. What was it exactly that they were like crediting them for? Because I didn't see what their
Well,
blog
I
posts
think
were.
they've all just worked together on the actual specification here. Like, it's not
Okay,
just
fair enough.
Cloudflare's.
Okay, fair enough. That's what I was wondering. I thought it was something like that, but I wanted to make sure because I didn't actually read the Facebook and Mozilla blog posts. So I wanted to, make sure I wasn't spouting off nonsense before
Yeah.
asking you. Yeah. All right. So North Korea.
Yeah, we can start talking about some real hacks here. Maybe.
Yeah. Maybe.
This yeah, I mean, I'm saying maybe because, like, obviously this was a real thing, but so the gist of this, basically, North Korean malware was found on a computer in the, I'm not even going to try and pronounce it, but I'll highlight it here on screen for those of you watching, within that nuclear power plant.
Udan Kalam, I want to say. I'll give it a try.
Yeah,
It's my best attempt.
yeah, I don't know, so I'll kind of avoid that. But basically, they found what was it? D-Track, I want to say. Yeah,
Yep.
D-Track.
Yeah, it was D-Track.
Oh, D-Track has already kind of been affiliated with. It goes by a few names. Lazarus Group, I believe they use in this article. Hidden Cobra is what U.S. Intel uses, or Zinc Group is what Microsoft uses for these guys. But essentially, it's attributed to North Korea, and that Lazarus Group is out of North Korea. Which is kind of the same group that WannaCry has been attributed to. Just for some context here with who this group is. D-Track itself, though, was a banking malware. Keylogger, browser history, and just kind of that general spying, like, on the process that the user had. It isn't a nuclear targeted malware. So that's kind of where I said maybe. Like, yes, they've clearly had some malware, but it sounds like this is really just like a more general purpose malware that ended up spreading onto their machine because, of course, within their air gap, they naturally had to have, that as they say, a single PC that was connected to the internet for administrative purposes.
Okay.
That was
So
on a separate network from like all the nuclear stuff.
yeah. So I think it's worth mentioning that this power plant, they initially said that it was like fake news, that no compromise had happened, or they, you know,
Yeah, they said it was fake information.
yeah. And then later on, they said, okay, we lied. It was real. Yeah, I mean, the features of the malware that was listed kind of support what you were saying with, it said it included features for keylogging, browser history, getting network info, list of running processes. It seems to be like a malware that's more for getting a foothold, like doing some reconnaissance and stuff. But I found some contradicting statements in here that kind of confused me, because they said that the KNPP incident looks more like an accidental infection, like you were saying, but they also said in there that the particular malware sample had included hard-coded credentials for the internal network, suggesting that the malware was specifically compiled to spread and operate inside the power plant's IT network. So they say that it's not meant to hit it, and then they say that it had hard-coded credentials for the power plant. So it doesn't really make a lot of sense. It's very contradictory what they're saying here.
Yes and no. I mean, so it had hardcode credentials, but we don't know if it was updated to have those credentials. Like if the malware got installed and then was updated once they kind of realized where they were.
Hmm.
I mean, so we don't have a lot of information about what actually was modified with this. All we know is that this was using that banking malware, which lends credence to that. But yeah, as you mentioned, that does raise some questions too over, well, if they did have hardcode credentials, that does seem targeted. But without really knowing what type of changes were made on DTrack, I mean, it's also possible then that this wasn't even North Korea, that somebody just took that malware and modified it. But
Yeah.
kind of going with what we have, I guess the other thing, they could just be trying to downplay, and this was a much more significant thing than was initially thought. For what it's worth, KNPP hasn't actually um, revoked their claim that it was false information. It was their parent company that confirmed it.
Okay.
So it
All
was
right.
kind of a separate company that went and confirmed the malware. Well, not separate, like it's a parent company, the Nuclear Power Corporation of India.
Yeah, I mean, I guess what surprises me the most is I'm surprised that nobody's really dug into this a bit further. Like usually when stuff like this happens, people really dig into it
Well,
and try
give
to
it
find as
time
much as they
though.
can.
This was quite recent.
Yeah, I mean October 30th. I guess that wasn't too long ago, but yeah, it's just weird. There's a lot of conflicting information that I think, yeah, they're hopefully gets answered, because
Yeah, well, it seems like this got out to Virus Total upload.
yeah, I saw
So
that
I
too.
mean, it's going to get looked at. At this point, though, we just don't have the information.
Yeah, fair enough. All right. So Pirate Bay went down due
Yeah,
to
and
malicious searches.
yeah, and usually this wouldn't really be news that we'd cover. It's the fact that these were malicious searches that happened to cause the denial of service. This reminds me, like it was ages ago when websites would let you search with regex, and of course regex you can do some depending on the support of the engine, you can make some pretty high CPU usage searches, and it's been a long time since I've heard about one of these denial of service, like resource exhaustion, denial of services through searches. So I thought this was just kind of a cool little thing. We don't have the details over what exactly the search was, but it was something with their Sphinx search server.
Yeah, and apparently
That
that
ended.
hasn't been updated now, so can't
Yeah,
can't try it now. It's no longer real world CTF. All
yeah,
right.
but I mean, I just wanted to kind of drop it in here. It's been such a long time since I've seen those, so I mean, I'm sure they're still out there. I just haven't seen it in a while.
Yeah, fair enough. So the web.com breach. So
Yeah.
there was a breach at web.com, so that includes network solutions and register.com. And they said they had an investigation, and it indicated that account information for current and former customers may have been accessed. So it's mostly PII, name, address, phone numbers, email address, stuff like that. They make it very apparent in in their post that no credit card information was stolen. I think they only say it like 15 times a paragraph. But interestingly, they state over again, like a lot, that they encrypt credit card numbers. So the encrypted credit card information might have actually been leaked. Because, like, usually when people say the credit cards weren't leaked, I think the reason for that is usually they store credit cards separately from PII, right? Like, usually it's in a separate database or something.
Yeah,
They don't say
usually
that's the
it would
case
be
here.
because the thing is, if the encrypted data has been leaked, odds are, well, it depends on the type of compromise, but oftentimes whatever server is accessing that also needs to be able to decrypt that information.
Yeah.
So yeah, usually they do end up going separate. But they do say we encrypted. It doesn't necessarily mean that um, that the encrypted information was leaked with this, though. It could be that stored separately, but they're also just trying to include, like, yeah, we encrypt this information and none of it was compromised.
Yeah, I just found it weird. Like, they have one sentence, they say, we encrypt credit card numbers and no credit card data was compromised as a result, which makes me think that they think it's not compromised because they encrypted it, not because they didn't get the encrypted version, you know? I think
Well, it says
should have
as a
clarified that.
result of this incident.
As a result of this incident, yeah.
Yeah, I've got it up here. So it's not saying that no credit card information or the credit card data wasn't compromised as a result of them encrypting, as a result of this incident. So as a result of this whole thing, the credit card information wasn't leaked.
Yeah, I don't know. I just think they should have been more clear on that because, credit cards obviously is like the big worry.
I think it's pretty clear, to be honest.
I don't know. I don't think it is. They don't state if, like, they don't, like, you could still interpret that to mean that they think that it's secure just because it was encrypted, not because it was separate. You know what I mean?
Well, I mean, the term as a result of this incident relates the whole thing, it not being compromised is being related as a result of the incident, not of them encrypting. Either way, that's kind of getting into, an English discussion, and we've already determined that you won't be an English professor.
Aw.
Which is a
All right.
reference to your exploit streams. If anybody's
Yeah,
kind of wondering
for
where that
anybody
came
who's
from.
checking that out, you'll get the reference. All right. So the BlueKeep attacks.
Yeah, this is another just quick news thing. Obviously the news we talked about BlueKeep back when Microsoft was warning people about it, being warned about those large scale attacks. Hey, it's finally happened, and it's pretty underwhelming.
Yeah, I mean, I think it was pretty funny because basically there's this group that's trying to use the BlueKeep exploit released by Metasploit to install cryptocurrency miners. So they're not using it for, like, even if they work, cryptocurrency miner is one of the less impactful ones, but it appears they're not even succeeding at it because apparently
Well,
there's
apparently
a
the
lot of
exploit's pretty
crashes.
fragile. Like, it's
Yeah, it
very
crashes on a
specific.
lot of people's
Yeah,
PCs.
it's determined on, and it's not like, I mean, it's BSOD, like blue screen. So, and that seems to be what also had them detected here, were a bunch of honeypots were blue screening.
Yeah, I think they said 10 out of 11 or something like that.
Yeah,
It was a very
so
low success rate.
although, so another company had kind of done a bit of write up on the on what they were seeing, like on the attack itself. They kind of talked through the exploit payload. So, have you done much with like writing egg hunters in terms of your payloads?
By like egg hunters, you mean like trying to find a tag that you
Yeah,
write into memory to try to find an object?
yeah,
I've done some
exactly.
stuff with it. Yeah.
Yeah, so the tag that this payload used was hex Buddha Kofifi 42069.
Awesome. Perfect. I mean, yeah, I feel like if you're trying to put it in real world malware, putting tags like that, it's just gonna make it so much easier for your shit to get detected. Like, all you got to do is scan memory for that, because, like, let's be honest, you're not gonna find that as a legitimate value in memory, like, at any point in time. So it's probably like super easy to scan for that and
Well, I mean, at
see
the
if you
same
have it.
time, your egg needs to be something unique. You don't want to have an egg that's, isn't to your shellcode.
That's true, but that's a very obvious egg. You know what I mean? Like, he could have made it more subtle. But
Sure, but I mean, at the same time, this is also like an attack on old Windows machines.
yeah, it's an end-day attack. So
Like, well, not even just being end day. I mean, this is like, what was it, Windows XP?
I mean, yeah, it's an end-day. But I mean,
well,
like,
yeah, but I mean, it's out of life or it's out of support operating system. Like, I mean, the people running this, I feel like if you're still running it, like, security's maybe not your big concern. Or
yeah,
perhaps security's a bigger concern because you have to keep running this whole thing.
yeah,
I could see that too.
yeah. I mean, judging by the report, it seems mostly like it was script kiddies that did this stuff. Like,
Yeah, I mean, it comes from as you mentioned, the Metasploit module for it, so...
and they didn't even, like, apply it properly, right? It crashes a lot, so, yeah.
Well, I think the Metasploit one might have crashed a lot, too. Like, I think just the exploit itself is very...
Yeah, but
system
I mean, like,
dependent.
I mean, yeah, if it was a serious threat actor, they would have tried to improve the stability of that.
Yeah.
So, yeah. Just kind of a funny post, just showing you that not everyone out there that is trying to get you is very good at it. Alrighty. So, the Untitled Goose game. So, have you ever played this game? I never even knew this was a thing until today.
No, I haven't, but it's definitely been pretty popular. From when it was announced.
What is it about? Do you know anything about it? Like,
so I don't play a lot of games, so I can't comment on that. That said, what it seems to be is like, do you remember that goat game?
I think I remember a bit about it. Yeah, the goat simulator, whatever it was.
Yeah, this seems to kind of be in that sort of vein, but you've got a goose. I don't think it's like as buggy or anything. Like, I think it's a bit more serious on that. That said, no, I don't have a huge familiarity with the game. I've definitely seen, screenshots on Reddit from it and stuff.
Okay.
Like, it's kind of become a meme over there.
Yeah, I don't know how I hadn't really heard of it. I feel like it'd be something that,
Yeah, I'm a bit surprised about that, actually.
Yeah. But anyway, it was vulnerable to a code execution vulnerability, and it was through deserialization in the save game loader. Which, that's a pretty common attack vector when you're hitting games. Save games are generally a pretty good thing to look in if you want to try to find bugs. Because I think a lot of companies, when they're thinking about save games, are not really thinking about it being hit. So they're maybe not as cautious when they're writing code that's parsing the save game. So yeah, I think it was...
That's true in terms of the save thing, but deserialization is another just common attack vector in general. User input in deserialized data is just bad news all around.
Yeah. And this was, what did they say it was? It was in, was it Visual Basic? I'm trying to remember.
Well, no, I don't know if it said what language, but it's a .NET.
Yeah, .NET.
Because the attack used here, they used Why So Serial, the .NET version of it.
Awesome library, by the way.
They use that to kind of generate the payloads. There isn't a ton to really go into here. It's a very straightforward, one thing I guess we can mention is that .NET doesn't have any universal deserialization gadget that gets you RC.
Okay.
So without that, it adds a little bit of work because you generally need to find something to deserialize. So I guess with deserialization attacks, what you're able to do is essentially craft an object. You control all of the fields in the object. You don't control any of the code of the object, but in theory, you control what object type and all of the fields of it. So you need to find some object that does something that you want to do with those fields and that you can actually get it to do whatever, or get that method called. So usually you're looking for something that has some sensitive action performed, like in the wake up function, which is called when it gets deserialized, or when it gets destroyed in the destructor, something like that.
Yeah.
Yes. So there's some challenges with it when you don't have that universal one. But there's been a lot of research into .NET. And basically, if you have certain libraries, so, this game used process.start, which gives access to a delegate that can be used for the attack. But like I mentioned, the why so serial.net thing builds it for you. So, it doesn't really help to dive into how that attack actually works. All they did was run a script.
Okay. Yeah, that's a good point on that. So another kind of fun thing. But getting a little bit more serious on the exploit side is there were a few Chrome 0 days that were discovered. One of them was actually being used in the wild, so they just got patched. So there were 2 use after frees. There was one in PDFium, which I guess is their PDF, what handles their PDF display and stuff like that, and a use after free and an audio component of Chrome. So the audio one was found by our friendly neighborhood Flats. Those of you who are, from PS4 community, you know who that is. I don't have to explain. I don't have to introduce him. Yeah, so he was one of the people who found the audio one, and that was actually the one that was being exploited in the wild. I tried getting some bug details. I don't know if it's changed. Last night, though, the reports were locked down. They had permission denied. Yeah, it prompts you for a Google login when you click the link, so they're still denied. So eventually, I think those reports will get unrestricted, and we'll be able to see more information on those. They might be worth checking out, just because browser stuff is usually pretty interesting, and you don't always get good reports on those. So
Yeah, I mean, it's like I said, we don't really know at this point. Might be interesting, might not be interesting.
with browser, I think it's pretty much guaranteed to be interesting, to be
The
fair.
audio one, I think, will be PDFium. I mean, PDFium, obviously, the PDF readers in general get attacked pretty heavily. So,
Yeah, fair point.
I mean, that could either be a sign that this is going to be like a fairly serious exploit, and I mean, it probably is given Google's general quality. Though I will mention that Banana Penguin is a great handle.
Yeah, it's a pretty great handle.
Especially to kind of go public under.
Yeah, one thing I think was of note in the like blog post or whatever was, did they usually disclose the payout amounts? Because I don't remember seeing that in a lot of other reports. Because they said for the PDFium, they said they paid out $7,500.
I'm not sure. So the thing is, this is under the Chrome release blog, which is also a little bit different for them talking about the exploits.
Okay.
Like usually when we're covering exploits, we're talking about something P0's put out.
Yeah.
So we're on the Project Zero blog, and they don't really talk about it for obvious reasons.
Yeah.
So yeah, I'm not sure. I guess I just haven't paid enough attention on that.
Yeah, I just thought it was weird. It's not something like usually you don't see payouts when like CVEs are put out and stuff. So I thought that was kind of cool. But yeah, hopefully those technical details go out soon, and maybe we can even do a stream trying to look at it or something. I'm not sure yet. But we'll have to wait until those come out. So I've been doing a lot of Android streams, and we actually have an Android topic today. I think we actually have a few, but this is our first one. So the title, for those of you who are listening, it's NFC beaming bypasses security controls in Android. So NFC is basically, I think it stands for near field communication or something like that. It's basically like, I'm pretty sure like when you tap a credit card or something to a terminal, that's NFC, for example.
Exactly, yeah.
So, and like they're even putting that in phones now. People are using their phones to pay stuff.
Well, I mean, it's been on your phone probably for the past decade.
Yeah, I mean,
it's definitely not. Well, it's definitely not a new technology. But what is kind of new is back in Android 8, Oreo had the. They went from just having a flag that you can, and I think it was in developer mode. You could uninstall or install apps from unknown locations and stuff. You just have to kind of check that box. And now with Android 8, they introduced it being like at the app level.
Okay.
So with the app level, what happened is basically by default, all of the Google signed service applications had permission to install applications. NFC service is one of those Google signed service applications. So putting 2 and 2 together, NFC, or using Android beaming NFC, it was allowed to install apps. So you get close to somebody and you can install apps on their phone.
Yeah, I mean, I'm a bit surprised that even made it through. Like, I feel like that would be something that would be caught fairly quickly.
I feel like it's something that could be easily overlooked. If you're writing that, it's like, okay, it's Google signed. What's Google signed? Google Play Store, like a bunch of legitimate things. It had to be somebody who kind of thought, oh, well, the kind of attack surface there. I could see it slipping through personally.
Okay, fair enough. Silly Jake, that's spooky. Yeah, absolutely is. One thing I did want to point out, though, is did you look at the timeline?
Yes.
Dude, it took them like took them 10 months to fix the issue from report.
Well, yeah, just
Like,
checking bug status, checking bug status, checking bug status, checking bug status again. Yeah, I mean, it seems like it took them way too long to patch this.
yeah.
Which, I mean, it probably comes down to is more than just like a if NFC don't give default permission. Like, there probably had to be some architectural change that came in with that.
Yeah. Yeah, it still, like, it just seemed like I just saw
It
January
took
30th and
yeah.
October, October 24th. Yeah, so like 10 months. Crazy for how long it took the fix to go out.
Yeah, well, I mean, technically, the fix came out at the beginning of October, but that's not much better.
Yeah, exactly. Yeah, I was highlighting the public disclosure. Yeah. Alrighty, so HTTP hop by or a hop by hop request. So I know you said this isn't really a new attack, but it was one that
Well,
you hadn't really heard of before.
I'm not sure if it's a new attack or not. That
Okay,
was
fair
kind of
enough.
my thing. Like, it was new to me, so I want to kind of cover it. My guess is that it's probably not totally new, but I mean, it's pretty rare that something just like I totally didn't know that.
Okay.
So the gist of this is you've got kind of two types of headers when you make HTTP requests. You've got your end-to-end headers. Those are things like your user agent, accepts, so like what content your browser will accept, things like that, which the server needs to know. And then there are hop-by-hop headers, which only really matter to kind of your first hop. So that might be the server if you're communicating right with the server. It might be your CDN or some reverse proxy or something like that. So what happens here is a connection header. If you provide, you can tell it what headers to treat as hop by hop, and then it'll just drop those headers when it proxies it on. So usually just connection closer. The most common place you'll see connection used is connection keep alive.
Okay.
And then it will drop the keep alive header when it proxies it on, or if it proxies it on. And obviously keep alive has the meaning for like the CDN itself to keep the connection alive. But so what ends up happening here, and this is I thought it was kind of interesting. So you can provide just whatever header you want into that connection, and by spec, I don't believe they're supposed to just drop anything, but there are certain attacks you could do where, like let's say you do connection, you put cookie in there. It might drop your cookies when it proxies it. Now, that's not going to be very useful in terms of an attack. But in theory, websites will do something like x-forwarded4. That's your header where when it redirects your request, because the endpoint no longer knows kind of the originating server IP, it just puts your IP into that header and forwards it along. So what happens if you drop that? I can say that I've definitely seen systems where it would read the IP from x-forwarded4, but if the IP was missing from there, it would treat it as localhost. So if you were to combine that with, it thinks you're from localhost, it might also have like a developer interface that's only accessible if you're right on the box itself. I want to say like GitHub or GitLab actually had an issue like this where you could spoof your IP by providing x-forwarded4 127.0.0.1 and get it, or no, maybe it was Stack. I don't know. It was some website that had this issue. I remember some years ago. Not this issue, but this sort of thing where it used that IP address to add in some permissions or add in some higher level access if you were coming from localhost. So the theory here is that you drop some important header using that connection tag, and then the proxy just kind of sends it along, drops that important header that the application's actually expecting, and I mean you can get some error messages out of it. Or as I just kind of mentioned, if you drop like x-forwarded4, you might be able to get access to something. A lot of websites don't do that, so this is pretty limited. But it's still like I wasn't familiar with this. Like I wasn't familiar that the connect header would do that at all in anything.
Okay.
So like that was news to me, and like there are some attacks here. Like that's definitely interesting.
Yeah, they mentioned a few. Like I think they mentioned fingerprinting, some cache poisoning, which I think we
Yes,
talked
they
about that
mentioned the
last week,
cache
didn't we?
poisoning. I think that's actually why they brought this forward was because of the cache poisoning aspect.
Yeah, which that is what we talked about last week, right?
Yes,
I'm
we were
not wrong.
talking
But
about
yeah,
the CP DOS stuff.
yeah, yeah. And then the other thing was the other big thing was the web application firewall rule bypass, which I think you were going into a little bit there with like X forwarded for and stuff like that.
Yeah, I mean, that's the WAF bypass. I mean, it's kind of saying, like, if the WAF requires the header, but then it also drops it because of that connection thing, like, okay, yeah, but I don't see that one.
Yeah,
Although, to be fair, I mean, as I've kind of made clear, I think in other issues, like, a lot of my background comes from attacking applications. I don't do, like, the network pen testing, or at least not as much, so running into the WAF was a little bit less common because most clients don't care about what their WAF can block. They don't want that issue to be in their software at all. So just give me direct access. Let me find the issues at that level. And if they want to suggest there's a WAF in front of it, great. But we're concerned about the code, not about that.
yeah. Alrighty, so let's talk about Windows Defender.
Yeah, and you already mentioned that this was a little bit unclear for you, and
Yeah, I had to ask you a little bit about what was going on because the slides were a bit unclear.
yeah,
Just going
so
through them.
I think part of that might just be, it seems like this was there's a Japanese fellow who wrote this. So maybe it's kind of second language thing. Maybe not. I don't want to presume to know what their first language was, but this is again kind of one of those exploits I came across. It's like, yeah, okay, that's fun. Useful, maybe not so much, but fun. So the idea is basically turning Windows Defender into an Oracle. If you're familiar with kind of a lot of Oracle attacks, or you can kind of think about it as like being able to ask Boolean questions about pieces of data. So the gist of this is using Windows Defender as an oracle in terms of when it rejects a file or when it rejects an output is technically what would happen here. When it rejects it, that means the file or gives you the true, and you can write the condition for false and basically ask that yes or no question on the basis of when Windows Defender rejects or accepts your file. And what this comes down to is in Windows Defender, it has, I guess, this smart feature. And it seems to be the only antivirus, or at least the only mainstream one that's doing this, but it'll look for script tags in basically all your files. And then if it sees that script tag, it'll go ahead and execute the script tag. And it'll look for evals in it, and it'll try and execute what the argument to the eval is. So they kind of show the specific case where this can be exploited. You kind of need to control data on both sides of some secret piece of data on the secret you want to go, because you have to, in order to be able to access whatever that data is in that JavaScript that Defender runs, you need to basically put body tags around your secret or around some piece of data. And then in that JavaScript, just document body inner HTML and you've got access. So now you can start crafting your yes or no questions to actually get kind of what that secret value is. So the yes or no questions, the thing is you need to have some way to force Windows Defender to actually reject your file or accept it. So obviously accepting a file, just don't be malicious. It's fine. Rejecting it, if you're not familiar with a lot of antivirus signatures, there's something called the icchy file, which basically it's this test file that it's all text. Icchy test file. Basically, this file, if you were to go save it or save that as like a text file, it's just a standard antivirus test file. You save that file, your antivirus is going to flag it. It's not malicious, but every antivirus or practically every antivirus will flag this one file. It happens to be a comp file that just prints like, antivirus test out.
Okay.
So anyway, because Windows Defender will flag that, if you have most of that string in your JavaScript, or like in your script that you're injecting, if you have most of that, and then I kind of mentioned how it does that evaluation into the eval.
Yeah.
I'm just trying to find the post here again. Since it has most of that information in the eval, when it goes to kind of process that eval, the talk itself goes in a little bit more, but if you basically have an eval and then you're able to give it that icar string, through the talk they just use the string icar as the example. Technically it's a much longer string, but doesn't really matter. The idea would be to generate something that will result in that when it's a certain letter. So they use like eval eic plus r.
Okay.
So like basically just trying to figure out what a character code plus whatever value ends up giving you the actual icar that's detected. So basically with every letter you access the one letter from the body, adding in, or find out what offset ends up basically causing that icar string to be complete and detected. So as soon as it gets detected, you know what letter was there, so you can move on to the next letter. So basically like 255, 56 requests for every letter you want to exfil. Requires Windows Defender, requires you control information on both sides of the secret that you want to access.
So not incredibly practical.
No, but I mean, is Windows Defender used? Like, yes, but on web apps, on things that you're going to have kind of this level of access to make all these requests to, a lot less common. They made a CTF out of it, so there's at least one CTF you can solve this way.
Oh, okay. There you go.
I won't say it's impossible, but I will say it's definitely limited. But it's a fun little attack anyhow, and I mean it is using an antivirus to do something a little bit malicious, so I can give it a thumbs up for that.
Okay. Yeah, I was just like listening to you and like, okay, because like I was pretty lost in the thing, so it was basically you teaching me what was going on there.
Well,
so
hopefully I did an okay job at that.
There you go. You're a professor. I may not be an English professor, but you're a Windows Defender professor.
Oh, wonderful.
You're welcome.
Yeah, so kind of our next topic here is some really bad PHP code. Surprise, surprise.
Yeah, rConfig. So apparently this is a network management tool. I haven't really come across it, but apparently it's fairly like it's used. It's not.
Yeah, I wasn't going to cover this until I looked and saw that rConfig was used by 3.3 million devices.
Yeah.
Which I mean, okay, isn't amazingly huge, but that's significant.
Yeah.
So I mean, let's just jump right to the code. If you know anything about PHP, you're going to recognize the issue here.
Yeah.
Root uname equals get root uname. A little later on, nothing really being done with that, just checking if safe mode exists. These are actual strings, but the website just happens to HTML encode them when displaying code. Then it creates the test command to check, because this is in, I think it was checking like if something's up or something, I forget. Or maybe that's the other one. Either way, creates a sudo command that sudo says whatever username you provide, and you'll notice like it just takes that right out of the get URL and
the straight up command injection.
And goes ahead and executes it. Like this is as straightforward as it goes. This is unauthenticated. Extremely straightforward issue. Like there's I try and be charitable with a lot of these things and explain kind of how maybe this could have slipped through and stuff. Trying to be nice. Like I have nothing to say here.
Can't do that here.
Like
it's just too incompetent.
It's a sudo. You're pulling in right there with the username. There's nothing. And I mean the other issue, the second one, and this document kind of talks about how they turn that into the shell, but you can do it yourself without doing a PHP reverse shell. Just you've got command execution. You don't need to use PHP anymore.
Yeah.
But the other one, the authenticated one, is basically the same issue.
Luke P, it's a file that only exists during install. Bad code, but doubt it exists on most servers. Only during install? I don't remember that being mentioned. I'm just looking through in case maybe I missed that. Because it's totally possible we did miss that, but I don't...
That is fair. It does mention it's part of install. I'm not sure when it's removed.
Oh, the unauthenticated one. Okay, so not both of them. Just okay.
Okay, so that does limit the attack surface. Thank you for pointing that out.
Yeah, that's a good point.
Because yeah, I mean, if it is just the install there, I guess it does show it's an install.
In the install directory, yeah. Alrighty. Yeah,
okay,
I mean,
yeah, we don't always read. You mentioned it's on the NetSec thread. We don't always get through everywhere everything's being talked about, but that's a completely fair point. I mean, it's still bad code. Like, I don't think you should rely on that, but that does limit where it can be attacked.
Yeah. I mean, this guy mentions he basically just ran a script that looked for like dangerous functions like exec and then just looked through them. So he probably found these issues in like under 5 minutes. So I mean, yeah.
So yeah, I mean, we don't really need to step through much here. I mean, I guess one thing I will mention is PHP just doesn't make it easy to do this securely. Maybe this has changed. So I used to write some PHP back in like the 5 days, not so much in 7. And I mean, what they had is you basically had your exec, your shell exec, um, eval, if you want to count that in here as being an exec thing. But you didn't have any sort of parameterized input. So in other languages, you'll be able to provide like exec, but you'll provide an array of inputs. So if you put user data into just one of the arrays, like you can't break out of the PHP array. It kind of treats it all as just the one argument and passes that over. Whereas PHP just treats it all as that one big string in all of their things. Maybe they've added something or something I'm not aware of, but I think you basically always have to do the escape shellers, or who knows, maybe it's now real underscore escape like MySQL had. But I mean, part of this does go on PHP just not making it easy to do this securely, but I mean, it's just bad code too.
Yeah, I mean, one thing I'll say is if there's issues that are this obvious, it indicates that the entire code base is probably riddled with other more subtle issues. So, if you're
Yeah,
looking for
sure.
something to audit,
Although,
this
to
is
be
probably
fair,
something.
I mean, I do see right here that they do a nice parameterized query. So, I mean, that's to their benefit.
You're giving them some positive
Hey, so I mean,
points.
parameterized queries, like for the longest time, like everything was dynamic queries and just like injecting input right into the query itself. So, I mean, at least they're doing that right. That said, I think PHP actually removed the old MySQL query interface.
I think they did
so,
too in PHP 7. Yeah.
Yeah, so I mean, this is kind of the way to go about it now, which is a
Yeah.
good move.
Yeah. But yeah, not too much more to go into there. They're pretty straightforward issues.
No, but we can jump on to talking about making an invisibility cloak.
Harry Potter is now real life. It's happening.
I mean, we talked about an issue actually really similar to this back on
Long time ago.
Yeah, it was episode 6.
Yeah,
and I mean, we've also so episode 7 we actually talked about something similar where somebody would walk in front of a TV screen showing a particular image, and any sort of tracking of the person would end up locking onto the TV screen, and they'd be able to kind of walk away without being tracked anymore. But yeah, episode 6 I think is the closer one to this, fooling automated surveillance cameras.
And one thing I want to say is it seems this paper's a lot more practical than the ones we covered back in that episode.
Yeah, this actually just seems like basically a little upgrade on that one. It does seem like they actually like are completely separate. Like this is a bunch of Facebook AI people who did this paper. Yeah, definitely a lot more practical. Essentially, so the one we talked about in the past was you would wear like this big necklace with a picture on it. And if that
really
picture
funny.
was facing the camera, it just wouldn't detect you anymore. And this is a really similar premise. It's just instead of having this picture that you wear, it's this picture printed on your shirt. Which is definitely a lot more subtle if you're going somewhere. Like people might think you have a really weird shirt, but it doesn't necessarily, like nobody's going to be too worried about that. Whereas the random picture hanging off your neck might
That's a bit more suspicious.
Yeah.
I mean, hell, the picture even looks kind of something like is that, it kind of looks like a supermarket. Is that what it looks like?
Well, they talk about kind of how they generated it. So yeah, like they started off with that picture of like a market, and they have a few other things kind of in there.
Yeah, okay, I see now. Yeah, one thing is I wish some of the pictures that were in this paper were a little bit bigger, because some of the pictures I wanted to look at, and they have like 6 or 7 pictures in like one half of the page, and it's just really hard to see what they're trying to point out.
Yeah, I mean,
yeah, you can
you get the idea from it though.
Yeah. So one thing they did mention was they showed some pictures and they showed that like if there was ripples in the shirts, like that one you have right there on the right side, the guys that have like ripples in the shirts, it still detects them, so that kind of breaks it. But they mention, so there's two kinds of attacks that people try to pull off with this kind of adversarial patch, I think it's called, as the method. And the two different attacks is either trying to fool the AI into thinking you're something you're not, so it'll detect you as like a different object than a human or something like that, or to just straight out try to make it think you're not there, which is what this paper's about. And apparently the one where it makes it think that you're not there at all is harder to pull off than trying to fool, like, I think, what's the names for them? I'm trying to remember. It's there are two different detectors. I'm trying to remember what they're called.
Well, object detectors or classifiers are the two things.
Yeah,
classifiers versus detectors.
Yeah. So this one is for object detectors, I think, instead of just classifiers.
Yeah, it doesn't care. Well, it doesn't want to be detected at all, not just detected or classified as something else.
Yeah. So, I mean, like, I like this paper because it's a lot more practical than the ones we've covered in the past. Obviously, like you were saying, the shirt, it's a lot more subtle. It's not, like, blatantly obvious. And it seems the success rate's pretty high unless you have, like, very obvious distortions in the image.
Yeah, I guess the one thing I would mention, though, is, like, they've only released this one image that works. So, obviously, this one image isn't, like, as soon as it's known, it's no longer going to be all that practical.
Okay, fair point.
That said, I mean, like, it shouldn't be that difficult to generate other images, and in fact, they kind of show some other things that they've tested here.
Okay.
But that is worth pointing out. Like, I mean, you kind of need some more general purpose thing for it to really be practical, where it's like just generating a shirt that does that, not the same shirt.
Yeah, exactly. So, I mean, it's been a little while since we've covered some AI stuff, so it was about time that we jump back into that a little bit. So
yeah, we used to cover it practically every episode, I think. But
yeah,
I mean, this was, I guess. No. But yeah, I mean, it's definitely like I said, practical. It's I seem to overuse the word, but it's fun.
All right, we have a lot of fun on this show, so it's fine. Getting into something a little bit less fun, well, actually fun for me, but I mean, actually a little bit scary, to be quite honest, is this Silhouette paper. So Silhouette, it's basically a proposed shadow stack for embedded systems. So the shadow stack, basically, the big thing they tried to protect against here is corruption of return addresses and preventing stuff like ROP. So it's basically a shadow stack is something that runs alongside with the stack, and anytime like there's a function return or anything like that, like when a new stack frame is entered, instead of what it typically does, which is pushing the return pointer on the stack, it pushes it on the shadow stack instead. So if you get like a stack overflow or something like that,
it'll push it on both also at times.
So
it pushes on both and kind of works like a canary, where it goes to return and it looks like, okay, from the shadow stack, oh, these don't match, something went wrong, get out of here.
Yeah. So it can prevent memory corruption, but I think the scarier part is it can prevent ROP, because now that it knows like every valid return point, like it knows which functions are actually functions, you can't just corrupt a return address or something like that, or a function pointer, to just jump straight into into an instruction in the middle of a function or something like that. It's not going to work, because they propose checking the shadow stack to make sure that you're jumping to a real function. So it's basically like a method of CFI.
Well, so this actually goes well beyond just the shadow stack, because the paper is, efficient intra-address space isolation. And the idea is doing that to protect your shadow stack, but this actually has a few passes that it does. One, if it is transforming the existing code to use the shadow stack, but kind of their novel thing here is that they're calling it store promotion, which translates all. This is targeted to ARM. It'll translate all of your store. All of your memory access code basically to use instructions that enforce kind of non-privileged access. So it's the store register with translation variants. I'm not an expert on ARM, so I can't really go into too much on how that level works, but essentially seems that it'll basically all of your user access, even if you're in privileged mode, so even if you're operating like, in kernel mode or whatever,
Yeah, EL1 or
it'll
whatever.
yeah, so even if you're doing that, it'll still only look up your memory access as though you're in user land or as though you're not privileged. And it translates all of your stuff to that, so only the shadow stack is in that protected memory. So there aren't just any kind of latent privileged memory access that could be used to even access or modify the shadow stack. And then it also does a CFI layer, so it adds on kind of the flow information or the control flow graph, and does some instrumentation to make sure that all of your indirect calls, it'll instrument all of those call targets, so you can't make any indirect calls going like into some random library that isn't secure.
Yeah.
And then it has a last scan for any final privilege instructions to make sure it's free of it, but that's basically just a sanity check at that point. So yeah, it has kind of like those 3 passes that it does with this. So I mean, it's more than just the shadow stack. Like, their key thing here is that store promotion, changing all of your memory access so you have nothing but unprivileged memory access except for where the shadow stack's being checked and used.
Yeah.
That way you kind of have that isolation. Sorry, I seem to keep kind of cutting you off.
That's okay. If you keep having this stuff to add, because I did kind of misspeak there, so it's good that you corrected me on that. But I said this was it was scary, and part of the reason for that is, like, when we talk about these mitigations, I always come back to what's the overhead, because when you're talking about like embedded devices and you're talking about dealing with stuff in the kernel and stuff like that, you want stuff to run fast, so overhead matters. And so I of course checked out what the overhead was on this. I forgot to mark down the page number so I could bring it up on the stream. I don't know if Z can find it while I'm talking about it, but it's actually a pretty small overhead. On the shadow stack, their mean overhead in their test was 1.06%, which is pretty small. And the control flow integrity stuff that Z was just talking about, it was 0.14%, which is basically negligible. Which they point out.
On the store promotion, it was 7 to 8% with a maximum of 20, and putting everything together, it was up to 48% overhead.
Yeah, I mean,
so though, yes, the shadow stack itself, but I mean, the shadow stack isn't resource intensive. The fact that they're doing the checks on every store, like by using the lesser privileged one, and all of that definitely adds to it. And I mean, I have an issue just with their benchmark suite itself. What they use is something called Beebs.
Okay.
So what that is the Bristol embedded benchmark suite. That's where they got like all the programs that they used. And the purpose of that is testing power consumption on embedded devices. Let's say these aren't really real world uses. Like, I mean, QSort's one of them that they're benchmarking with. Like, there are things that are going to use the CPU in different ways, but they're not things that are really what you're actually going to be running. I feel like the actual programs that you're going to be running are maybe going to have more indirect jumps than your quick sort routine's going to have. Just using that as an example. So I think there's kind of a bias for this to come out a lot lower than what this will actually be. And in fact, I think like even just the 9% is pretty high for embedded stuff to add on a 9% overhead. Because that was their average. 9.23% when everything's put together was their average overhead. And I think that's low because of the programs that they're using. And to be fair to them, I don't know what I'd suggest they use for benchmarking. It just feels like the wrong thing to benchmark because they're not real applications. They're implementations of specific algorithms, and they definitely give you an idea, as I say, of the power usage, which is what they're created for.
Yeah. Okay, so I found the results kind of scary, but you're challenging that maybe it's biased. It's not really.
Yeah,
like
I'm not
those samples and in the intention of making it seem more efficient or more like performance.
I don't think they were. I don't think they were malicious or had any ill intent with what they selected. Because I think that is kind of a standard benchmark suite for embed stuff. I don't think it makes sense for testing this sort of performance. I don't want to imply any sort of ill intent on their part. I
Okay,
just
fair
think that
point.
was a
Yeah.
poor selection.
Okay.
I mean, from like a more technical standpoint, like if this were coming on desktop, like I'd be more worried because desktop doesn't really seem to care about performance. But being that's focused on the embedded stuff, I do think that 9%, like I'm not as worried about it. I think it's an interesting idea. But I think any application that also just needs its own privilege, like I think that's an interesting idea to kind of use that privilege access as a way of isolating memory,
Okay.
such that even if you have an issue in kind of privileged code, that memory's still protected. You're still not able to corrupt the shadow stack. Like I think that's an interesting idea, but that's also where most of the overhead came into. The shadow stack itself. I mean, there's a ton of attacks that just don't require overriding the return address, or you can deal with getting around that. I mean, heck, pretty much. I think we kind of touched on the whole co-op attack on maybe a couple episodes ago.
Can
Or
you
like,
refresh my memory a bit on that? Because I'm.
well, we didn't talk about co-op itself, but one of the papers I think mentioned co-op attacks, which is a C++ method of basically setting up all of your. It basically bypasses control flow integrity checks because they don't really take into account virtual functions in C++. So you're able to create like
Okay.
your full chain using those virtual functions. So like there are plenty of attacks that don't require you to violate CFI or to violate the shadow stack.
Okay. You brought up desktop, so I am gonna ask: do you think we see something like this on desktop type stuff in the next couple years?
Shadow stack, yes. The isolated memory, no. I
Okay.
mean, wasn't Rust actually at one point? I think Rust actually at one point might have even defaulted to using a shadow stack. This was well before 1.0. I think this was a while back. And I could be mistaken, but I want to say Rust actually at least talked about defaulting to using using a shadow stack. So like
Yeah, I
I
wouldn't be
definitely
surprised because Rust is pretty like security is one of their pillars, I guess.
yeah, like well they're definitely very security conscious.
Yeah.
So like I can see a shadow stack coming on desktop. Like I maybe not everywhere or everything. Like I don't see it in the immediate future becoming like, stack canaries are where like your default compiles on GCC has stack canaries enabled. I don't see shadow stack quite becoming that, but I don't think we're too far off from seeing shadow stacks.
I feel like if we see it anywhere first, it'll probably be maybe Mac OS. Just because I know Apple, they're usually pretty quick to on the mitigation game. Quicker than
Yeah, well,
most
so does
others.
iOS actually implement a shadow stack or anything? Because I could see it coming to mobile.
Yeah, that's what worries me a little bit. I'm starting to look into Android stuff, and this stuff's scaring me. Like you're trying to you're trying to mitigate all my shit before I even get started. um, I don't know if Android does a shadow stack, or sorry, iOS does one. I don't remember hearing about one. But that being said, obviously neither of us do iOS stuff, so there very well could be one. I
Yeah,
looked
I
it
mean
up.
they
I don't
because
really
they
see
have
anything.
stuff, so like they have some interesting mitigations there. So it would be interesting to know if they don't have it, why they don't have it. And if they do, then now we know. But so I mean, they have the pointer. Maybe it does have to do with the overhead, but I don't think it usually has a ton of overhead. Maybe it just doesn't protect against as much as it seems to.
Well, one thing that I am just remembering is I think we should consider iOS does have pack, which is
Yeah,
kind
the
of a form of
pointer.
CFI, right? Like you already can't just jump anywhere you want, right? So on the CFI front,
Yeah, which is
it's already kind
true.
of protected
Yeah.
there with packs. So maybe they
Yeah, I mean,
maybe they
it
won't get
wouldn't
it.
add much more, if any, extra protection. Yeah, it's a fair
Yeah.
point.
And with Android, I think they are still trying to get pack in there. I know they've had some issues with like I think the way they spawn processes. Pack doesn't like it. It'll just crash everything. So maybe we won't see this on Android either, just because pack may fill that void that this would fill. So for mobile,
True.
that is
Yeah.
maybe a consideration.
Yeah, I know. I That's actually a really good point, though. Like there are other mitigations in this field besides just the shadow stack.
Yeah. So back to talking about fun stuff, we have unfork. I thought this was really silly. I mean, so basically what this is a little tool, and it's the inverse of fork. And what they mean by that is so fork splits one process into two. You get a parent process and a child process. This unfork tool joins two address spaces into one. I can't really think of many practical use cases for that. I mean, they even have a Q&A here saying that doesn't sound very useful. And then they joke that's more of a comment. And they say, think of the technique as taking a cheap snapshot of another application that you can read, write, execute, discard, repeat, all while leaving no p trace and sending no signal.
Well, so, and I mean, that is actually a very valid use case. That is kind of the use case of, say, you have an application that you can't just patch very easily, that you can't modify because it does integrity checks. Well, so you do use this to kind of merge it into your own address space so you can do everything. And what it essentially does is basically sets up like a user fault FD to create like a handler for your page faults.
Yeah.
And process VM read V, so it can read into the target memory. Basically, whenever you try and access memory, it faults. It'll go read the other process and read it right into your address space. They'll start off by taking Bitcoin. Like, it's more technical than that, but the gist of it is it's an address space that you control. You're able to now modify and do things, even if there is integrity checking on the original. So it is something that can be useful.
Yeah. I mean, they mention on 32-bit systems it's harder because you have a lot higher chance of collision with virtual addresses and stuff like that.
Yeah, less room to inject yourself. Because all of this needs to happen in a fairly small bit of memory because you're wanting to include their entire address space. So you need to kind of include yourself somewhere they're not going to be.
Yeah. I did have one thing though. I looked through it a little bit, and it seems they do copy the address space, right? Which is cool. But when you're talking about processes, obviously you have more than just the address space, and one of the other important things is something like FD tables, file descriptor tables,
which you don't get.
So that is an important distinction, because if that other application is it's opening files and stuff and doing stuff with them, or anything like pipes or anything like that, you're not going to get those file descriptors. So that could be, I think that's a consideration that they don't really mention here.
That's a big limitation. I think they do mention that here in the how limited is this approach section.
Do they talk about the FD
I believe
table?
So. They definitely mentioned that.
Oh yeah, they do say not files or shared memory. Yeah. They say you get the virtual memory and TLS, but not say files or shared memory. So they do mention that. Yeah. I didn't see that when I was reading through it. All right. But yeah, that is an important thing to note. The other thing I wanted to point out was the guy who did this, White Cork. He's a pretty well-known guy in the infosec space. I mean, he's an LLVM subsystem maintainer. I've seen him on Twitter quite a bit. Him and Hector Marcan were working on a Glasscloud board or whatever. It's basically a board they were working on that was laid out in the same way that Glasgow was. So I've definitely seen his name before, and I think probably some of the people listening probably have too. So it's a project by a notable name too. So I thought I'd point that out. Did you have anything else to add on there? I feel like I kind of cut you off, so I just want to make sure.
No, I think that's about it. I was really just going to get onto the restrictions with it, which is exactly where you went. I mean, okay. So we can jump into our last topic actually here for the episode, which is destroying x86 64 instruction decoders with differential fuzzing.
Yeah, so I'll be honest, they even say here that x64 or x86 64 decoding is hard. Yeah, dude, I'd never ever want to put myself through trying to write an instruction decoder for x86 on my own. It's probably like one of the hardest things you can ever do.
Yeah, for anybody that's kind of listening maybe isn't familiar, one of the difficult things about it is, or at least part of the difficulty comes from the fact that the opcodes in x86 and x86 64 aren't of any sort of static size. So that means and your instructions aren't of any static size. So like with RISC, so like ARM, I believe will use a fixed size instruction. So like basically every instruction can only be decoded one way. x86 based stuff, one instruction might have like 8 different decodings depending on where exactly in the bytes you start trying to decode it.
Yeah. And I mean, another issue with x86 too is you got a lot of like extended stuff. Like I think they even mention here SSE. Like there's a lot of really weird instructions in x86. I mean, hell, there's a Twitter account dedicated to making fun of x86 acronyms.
Yeah,
So,
I mean, so I think it was so this reminded me of another project called Sandsifter, I think it was. I think that I've got it.
I've heard
I
of
should
the
have it
name, definitely.
Yeah, Sandsifter. And it was for fuzzing your CPU instructions. And I mean, the thing is, even at that, they found like, thousands of undocumented instructions in their CPUs. So I mean,
Yeah,
like
that
at
was
that level, like x86 stuff has a lot of instructions, and that's another thing of the whole CISC versus RISC debate. Um, Obviously, with fixed size instructions, you also have a fixed size like you can't expand too far with that. Although ARM likes to push it with quite a few instructions. I guess one good point here made by Real Nano user is that Nano decodes x86 really well. So go Nano.
Go Nano. Yeah. Yeah, I mean, I think you brought that up, and I think that reminds me, I think Sandsifter was used by Christopher Domus last year when he was doing that Skylake CPU talk. He was talking about finding an undocumented like backdoor instruction set, and I think he used that as well.
I think he's the one who wrote it.
Is he? I don't know. I want to see now, because Sandsifter, let me see.
Yeah, XOR EAX.
Yeah, you're right. Yeah, he did write it. Yeah, so it's basically like analyzing the frequencies and stuff at the CPU, right? It's really low level, so I don't want to go into it too much, but it's pretty cool how it works.
So actually, it operates in a few different ways to do there are a few different options you can run it, and it does actually support doing this differential type fuzzing, where it'll pass the instruction there and over to some disassemblers, note any differences. It does actually support a similar mode to what this from Trail of Bits is offering. So Trail of Bits has offered a tool with this that Mishigo is what they're calling it. Probably butchered the name. But the gist of this is basically it's a fuzzer for various disassemblers. It'll just feed the instructions into basically 4 or 5 different... they list all of them.
Yeah, they have like Capstone, Zydus, XCD. They have a few different libraries. I think that's what we're talking about, right? Yeah. That is one thing I found cool too, is that they mentioned Zydus, which I think we talked about a few episodes ago, didn't we?
We talked about the release.
Yeah. So, and they actually mentioned that through the testing that they did, they actually found that Zydus was one of the better ones. They recommend either Zydus or XED for people who are writing disassemblers and stuff, because they found the least amount of issues in those. I think they found the most issues in Capstone, actually. Like a few things they found that nonsense decoded to valid SSE instructions. Can't blame them too hard there, because SSE is really weird, it missed instructions. So yeah, it seemed that they said that Capstone was probably the worst one in terms of how many issues they found, though it's the most popular one too. So I'm just going to scroll down to some of those issues that it found. So here's Capstone. So that's the one I was talking about, where it had these nonsense opcodes, and Zydus and XED, it failed on them. It said they were invalid instructions, but Capstone said it was this PH sub D, MM1, MM4.
Maybe really Capstone just knows more.
Maybe Capstone's just godly.
No, yeah. It is probably a bug there, but this is one of those things, like, I don't see myself using this in any immediate future, but it's still kind of interesting. Yeah,
because I kind of have wanted to get into writing some more RE focused tools, and that would involve some like disassembly stuff. So
but I mean, do you really need a fuzzier disassembler?
Oh, not fuzz it, but I mean the information,
which is what this is.
True, but some of the information it found with it, like finding that Zydus was generally more resilient, was that's fair. But information.
That's useful information for sure.
Yeah.
Definitely not trying to say anything against that, but I don't see myself using the tool release here. I mean, it's an interesting tool. it's kind of cool to talk about. In terms of how that's going to practically affect me, though, like even finding an issue there, like it's not very off. So it could be interesting if you found an exploit, if you eventually found your way to exploit like Capstone through one of these improperly disassembled instructions. That could be a fun, like a way to go about attacking something, but it would be, as I keep saying, the word fun.
Yeah.
Not super practical, just fun.
Yeah. Real Nano User, the thing about XCD and Zydus is you're locked into looking at x86. Oh, so they don't have disassembly for like ARM and stuff? I didn't know that. I thought no, Zydus does, doesn't it? Because I think I remember looking at it on stream, and I think they supported a few different architectures. I'm gonna look it up really quick. Zydus, so they have x86. Okay, maybe you're right. I thought they supported ARM as well.
Well, it says AMD 64. Maybe you just kind of remember reading that.
Oh, okay. Yeah, maybe. All right. Yeah, that's a good point. Thanks for bringing that up. Yeah, the only other thing I was going to bring up there, it's kind of related, not totally related, but it mentioned that it found the most issues with Capstone, and I actually, funnily enough, I did encounter an issue with Capstone with REBot. I don't know if you remember. It wasn't with x86. It was with PPC. There was a PPC instruction where if you passed it to REBot on Discord, it would crash the bot because it would crash the Capstone library. Because I forget exactly why, but it did crash it. I'm not going to say what that I don't remember what that instruction is, but if I did, I still wouldn't tell anyone because I don't want people crashing the bot.
It just sounds like you're not writing very resilient code.
No, it's entirely Capstone, or it might be Keystone, but it's one of those two, Keystone or Capstone. It's one of their faults, not mine. I made sure to check. So, but yeah, I thought that that was vaguely related. I thought that'd be a fun little thing to toss on the end there. But yeah, that was our last topic. We said it at the beginning of the show, but I'll reiterate: we're going to be doing more exploit streams. Pretty much, we're going to try to definitely hit Friday, but I think we're going to do more than that. We can do some impromptu streams that aren't scheduled, but we just want to stream at that time because we're looking at it and we think it'll be fun to stream it.
Yeah, but we are looking kind of specifically those Friday evenings, starting kind of a regular looking at different exploits. It won't always be Android specific, or it won't always be like kernel level. I want to take a look at that PHP issue, that not the one from this episode, but the PHP issue, the underflow from 2 episodes ago, I think it was. Like, I want to take a look at that at one point. Just taking a look at different exploits is kind of our regular Friday evening stream. Oh no, Spectre, do you know what time we were thinking about starting that at?
Like the Friday night streams?
The Friday ones, yeah.
Yeah, I think probably 9:00 seems to work really good. No, Eastern, so, that is Eastern, obviously. Yeah. So for you, that would be 7:00.
8:00 now.
Yeah, 8:00 now. Yeah, the time zone's changed like just yesterday, so it's confused me a little.
Whatever, 9:00 Eastern, whatever that is in your time zone. I'm sure you know how to figure it out.
Yeah,
hopefully.
The other thing is we are looking to do some more like discussion streams and stuff, but we still have to work out some details on that, so we'll let you guys know. And then the only other big thing that happened was the like Twitter handle change and stuff like that, which by the way we do have to update the overlay. I just noticed that.
Well, I haven't made that change yet. I'm kind of giving everybody a warning here. I'm going to do that later in the week after we've kind of released the audio and stuff.
Okay, fair enough. All right, sounds good. So yeah, that's pretty much everything we wanted to cover in this podcast. So if you guys are going to tune in on the streams later on in the week, we will see you guys then. And we will be doing the podcast again next Monday, and we will see you guys then.